Okay, so we're going to finish off chapter 3 with some exam questions that really kind of pull together everything that we've learned about in statistics so far. 2 of them are large data set, 1 of them is a non-large data set question. So this one says that Helen is studying the daily mean wind speed for Camborne using the large data set from 1987. The data for 1 month are summarized in table 1 below, so we don't know which month this is. Calculate the mean for these data. Well, I've actually just put it in as 10.2 here. I'm not going to actually have done this one on the calculator for you now. You can just put all of these values that you've got into your calculator and calculate the mean. Obviously, you would not include these ones here because we don't have any data for them. It then wants you to calculate the standard deviation for these data and state the units. Again, you would calculate the standard deviation straight from your calculator, but what I am going to add in here are the units. Now, it's wind speed, and wind speed, you should know, is measured in knots. So you can either write kn or you can write the word knots for this. It then says the means and standard deviations of the daily mean wind speed for the other months from the large data set for Camborne in 1987 are given in table 2 below. The data are not in month order. Using your knowledge of the large data set, suggest giving a reason which month had a mean of 11.57. So if we think about this, we've only got 6 months in the large data set. They go from May to October, May, June, July, August, September, October. We've just calculated that this month had a mean wind speed of 10.2, and then the other ones have got 7.58, 8.26, 8.57, 8.57, and then we want to think which month might be 11.57. Well, just think about what the weather is like between May and October. Usually you should realize that things get windier in autumn. So the later into autumn it is, the windier it is. There's another reason that we know it's going to be in autumn, because in the UK in 1987, there was a hurricane in October. So the month that we're going to suggest had a mean of 11.57, we're going to suggest that it is October, and we can either say that autumn is windier in the UK, or you could say that there was the hurricane or the storm in October 1987. And actually, they will accept September as an answer here as well, as long as you're talking about it being windier in the autumn. So it's just a little bit of kind of common sense with this. The data for these months, as in A, B, C, D, and E, are summarized in the box plots on the opposite page or up here. They are not in month order or in the same order as in table 2, so everything's been jungled up. And it wants us to state the meaning of the star symbol on some of the box plots. So we can see there's a star symbol here and here. Well, we know what that means. That means that they are outliers. So we'd get a mark for saying outliers. Then it wants us, for the last part, to say, suggest, giving your reasons, which of the months in table 2 is most likely to be summarized in the box plot marked Y. So we want to know, for this box plot that we've got here, which one might it be from this table that we have, okay? Well, I'm going to try and eliminate some of them, and then we'll just take a sensible guess with them, because it does say suggest which one it could be. Well, I look at a couple of things, right? I want to look at the median of this, because that's going to be similar to the mean. Usually, we would expect a median to be roughly equal to the mean. So the median for Y looks like it's one of the lowest out of all of these. This one's really high. So I think I know which one this is going to be. I think this one is going to be E. So I definitely don't think my Y box plot is going to be E. So that's one of the reasons I don't think it's going to be E. But if you look at these, their means are all pretty close. They're all between like 7.5 and 8.57. And so it's a bit difficult to tell which it would be of these 4. So I've done one comparison there of the mean. I now want to have a think about the standard deviation. Now remember, the standard deviation is how spread out the data is, or what kind of range that it's got. And if we have a look at, say, I don't know, this box plot, this one's got a really small range overall, and it doesn't have any outliers. So I think this one is probably going to be corresponding to A, because it's got the smallest standard deviation. These ones have all got a really similar standard deviation, but this one's got quite a small standard deviation. You can see that Y is very wide. It's even got this outlier that we've got here. So I don't think that it would be A. Now, if I had to guess, I probably would have guessed B because it looks like it's got a smallest mean out of all of these ones here. It's really difficult to say, to be honest. But if you guess B, C, or D, you would get a mark as long as you give these reasons that go with it, as long as you don't say A or E. So let's actually answer this. Let's say I would suggest for DII, box plot Y is likely to be month B. It has a low median, suggesting a low mean, and B has a low mean. Y also has a larger range than other box plots. So it has a standard deviation larger than A. B is a suitable month. As it doesn't have the smallest standard deviation. So let's just see how they said this in the mark scheme. So obviously I did these ones on the calculator, but you do get a mark for it being knots. October because it's windier in the autumn, or it's the month of the hurricane, or it's the latest month in the year. We've got outliers, and then here we've got Y has a low median, so we'd expect a lowish mean. So Y has a big range or interquartile spread, so we'd expect a larger standard deviation and suggesting B. But you'll see here that they've just said you just have to choose B, C, or D, and you need to try and do something that mentions either the mean and the median, and something that measures something to do with spread, so the interquartile range and the standard deviation, to kind of pick either B, C, or D that we've got here. I don't like that question. I kind of feel like there should be a right answer, and the fact that all three of these months are really similar makes it feel very difficult to know which one Y is. I would have preferred them to say, like, which one do you think this one is, which clearly is going to be E, or this one, which I think would be A because it has a low median and a small standard deviation. So I'm not super keen on that question that they asked there. Okay, we're just going to do two more. So this one, we're now talking about Charlie is studying the time it takes members of his company to travel to the office. He stands by the door to the office from 8:40 to 8:50 one morning and asks workers as they arrive how long their journey was. State the sampling method that Charlie used. So hopefully you've memorized this, but this is just opportunity or convenience sampling. He's just doing it as they arrive. State and briefly describe an alternative method of non-random sampling that Charlie could have used to obtain a sample of 40 workers. So it has to be non-random. Well, if you said stratified, or if you said random sampling or systematic sampling, those are all examples of random sampling. So the only other non-random sample that we could do is quota sampling. So I would want you to write down quota sampling for this. And maybe he wants to do it by gender. So he could just briefly describe. So he could collect 20 male and 20 female and ask them as they arrive. Or you could do it by age, or you could do it by all sorts of things, really. But I would just go with gender as quite an easy one, or sex then. So then it says, Taruni decided to ask every member of the company the time X minutes it takes them to travel to the office. State the data selection process that Taruni used. So she's going to ask every member of the company. Well, if you're asking every member, this is going to be a census rather than a sample. Taruni's results are summarized by the box plots and summary statistics below. Write down the interquartile range for these data. So let's figure out what the interquartile range is. The interquartile range is going to be the upper quartile, take away the lower quartile. Well, the upper quartile is there, which is going to be, these are going to represent 2, so it's 52, 54, 56, 58. And the lower quartile is 26. So we'll do 58, take away 26 for this, which is 32. So that is part D of the question. Then it says calculate the mean and standard deviation for these data. So the mean, x bar, is going to be the sum of the x values divided by how many there are. So that's 4133 divided by 95, which is 43.5. 43.5 minutes. And now we're going to do the standard deviation. So the standard deviation, we know is the square root of the mean of the squares, so that's the sum of x squared divided by 95, which is n, minus the square of the means. So the mean is 4133 over 95, and that's all going to be squared. Okay, I'm just going to put that sum of x squared directly into my calculator here. So that's going to be 202, the sum of x squared is 294, over 95. Mean of the squares minus the square of the mean. So it's 4133, 4133 over 95 all squared. And that gives me 15.39 minutes. I've done that one to 2 decimal places, and I've done this one to 1 decimal place. Don't ask me why I've suddenly changed halfway through the question. State, giving a reason, whether you would recommend using the mean and standard deviation or the median and interquartile range to describe these data. So I would look at this and I would think, there's a couple of really big outliers up here. And when you look at these different kinds of things that you've got, we've either got the mean and the standard deviation or the median and the interquartile range. Well, the mean and the standard deviation will take into account every piece of data, whereas the median and the interquartile range will ignore the extreme values. So I think the better one here is going to be the median and the interquartile range because of the outliers. So I would say, because there are outliers, the median, I would recommend the median and interquartile range, as these don't take outliers into account. Then we've got the last part. Rana and David both work for the company, have both moved house since Taruni collected her data. Rana's journey to work has changed from 75 minutes to 35 minutes. So I'm actually just going to put it on the graph because it might help us. So Rana was at 75 and she's moved all the way down to 35 minutes. So 35 is over here. So Rana has gone from this one to this one. David's journey has changed from 60 minutes to 33 minutes. So here's 60 and here's roughly 33. Okay. Explain which two values. Oh, sorry, Taruni drew her box plot again and only had to change 2 values. Explain which 2 values Taruni must have changed and whether each of these values has increased or decreased. Well, this one is not going to change, right? Because nothing has moved around there. This one is not going to change because that data hasn't shifted. Nothing shifted underneath it. This one isn't going to change either because it is still the maximum value, and these were not the maximum value before. So that makes me think it's the median and the upper quartile which are both going to change, because we've got something bigger going to something smaller. So the median is going to decrease and the upper quartile is going to decrease because there is more data in those in that bottom 50% and bottom 75% of the group. You can see how this one's above the upper quartile and then moving below it. This one's above the upper quartile and moving below it. In fact, they're both above the upper quartile and the median and both moving below the upper quartile and the median. So for G, we would say the upper quartile and median would both decrease. This is because both values have moved into the bottom 50% or bottom half of the data, decreasing the upper quartile and median. Okay, let's have a look at all of this then. So we've got the opportunity sampling, quota sampling, taking 4 people every 10 minutes. Well, they've also got some other bits down here for the quota sampling. You could say a description of how it might work. So you could say time slots, departments, gender, age groups, something like that, but nothing to do with random. You can't say stratified, systematic, or random. Census for part C, we got 32 for the interquartile range, 43.5, and 15.39, which was 15.4. And then we've got their outliers in the data, so it will affect the mean and standard deviation, therefore we use the median and interquartile range. We said that the median and interquartile range don't take in the outliers into account. And here we've said that the median and the upper quartile are the values that do change. More values are now below 40. More values are now below 40 than above, so Q2 or Q3 will change and be lower, but both of them will actually be lower. They've done it with specific numbers. I think what we've said here is absolutely fine, and we've also got some indication on the diagram. They're both dipping below the median. It's because both values moved into the bottom 50% of the data. Okay, so I'm going to do this last question, and this is another large data set one that we've got here. If you are trying this one yourself before you see me go through it, unless you've studied year 2 stats, which I don't imagine you have done, you will not be able to do part D here. Okay, so let's have a look. It says this partially completed box plot in figure 1 shows the distribution of daily mean air temperatures using the data from the large data set for Beijing in 2015. An outlier is defined as more than 1.5 times the interquartile range below Q1 or above Q3. The 3 lowest air temperatures in the data set are 7.6, 8.1, and 9.1, and the highest is 32.5. So let's complete the box plot showing clearly any outliers. Okay, let's quickly see if we can just grab these values. So this top value looks like 26.6, and this looks like 19.4. So I think we're going to need to figure out what the interquartile range is. So it's 26.6, take away 19.4. 26.6, take away 19.4, it's 7.2. So let's work out our outlier boundaries. So the lower boundary is going to be Q1, which is 19.4, minus 1.5 times the interquartile range. So that's 19.4 minus 1.5 times the interquartile range. That's 8.6. So 8.6 is the lower boundary, which means that 7.6 and 8.1 are outliers. Let's do the upper boundary. The upper boundary is going to be the upper quartile, which is 26.6, plus 1.5 times the interquartile range. So it's 26.6 plus 1.5 times the interquartile range, which is 37.4. And our top value is 32.5. So there are no upper outliers. So I'm going to put onto the graph the 7.6 and the 8.1 as outliers. So my 7.6 and my 8.1 as outliers. And then my next one is 9.1. So I can go to the graph and I can, at 9.1, put on a little line here. And then I can draw the box plot all the way across. And then my maximum value is 32.5. So let's go to 32.5. And I can draw that across. Luckily, that's going to straighten out. So we've got the 2 outliers and we've got the other bits drawn there. 4 marks, seems pretty generous. Using your knowledge of the large data set, suggest from which month the 2 outliers are likely to have come. So this is all of the data for Beijing in 2015. Now the outliers are talking about the temperature, they're the coldest ones. Now remember that the months that we have for the large data set are between May and October. You've got to think to yourself, when is it going to be the coldest in China at that time? Is it going to be cold in May, June, July, August in the summertime? Or is it going to be cold as it gets further on in the year? So I would say, using our knowledge of the large data set for part B, the outliers, I think, come from October. The outliers are likely from October, as this is the last or latest month in the large data set. Okay, and then it says, using the data from the large data set, Simon produced the following summary statistics for the daily mean air temperature X degrees for Beijing in 2015. Show that to 3 significant figures, the standard deviation is 5.19 degrees Celsius or centigrade. So this is pretty tricky because the standard definition for the standard deviation we normally think of as the mean of the squares minus the square of the mean. However, we can't work that out because we don't have the mean of the squares. So I'm hoping that you remember there was this alternative one, that the variance was this summary statistic SXX divided by n. So if we want to find out the standard deviation, we will do the square root of SXX divided by n. So that's going to be the square root of 4952.906 divided by 184. So let's hope that we get the 5.19 that they've said. So that's 4952, the square root of 4952.906 over 184. And luckily we get 5.188, which is 5.19 degrees centigrade to, did they want it to anything? 3 significant figures, to 3 significant figures. So very tricky to use this formula, but I did mention it earlier on in chapter 2. So let's see, we're not going to do part D because that's using something called the normal distribution, so we won't do that. So we did get the correct value of the interquartile range, and we did identify these boundaries. We've got this drawn correctly here. Why have they gone all the way up to this end? I don't think this is correct, because the highest air temperature should be 32.5. So I don't understand why they've decided to have those going all the way up there. That is not very good. Maybe they've got theirs with the boundaries drawn instead, but I prefer the way that we've done ours. Ours would definitely be correct. And then we've got the summary statistic bit that we've got here. Okay, so that's everything on chapter 3 with some exam questions at the end for you.